So in question 2, we have log equations again. And in A, there's actually a shortcut that I'm going to show you. And I'm going to show you the regular method as well. Okay, but I'll show you the shortcut first. I think a lot of you will like it. We're solving for a log, which means that we want to get a single log. So most students would start by saying, well, at least I can do is on the right-hand side, I'm adding. Adding means multiplying inside the log. And this is where the shortcut comes in. And the shortcut only works if you have a log equals a log. And the shortcut is very similar to a shortcut we did in exponents. What do you think I can do next if I go so? Does it make sense to you if log of 6x is equal to log of x plus 6, x minus 1, that the 6x would have to equal the x plus 6 times the x minus 1? Do you see that shortcut? It's the same shortcut that we did when you had something like 5 to the x equals 5 to the 7th. So, x is equal to 7. You could solve that with logarithms. But isn't it a lot easier just to say, so x equals 7? This will only work as a shortcut if you have a log on one side equal to a log on the other side. Now, if I wanted to solve this, I'm like, oh, it's a quadratic equation, but I can only solve quadratic equations when one side is equal to 0. So I have to multiply out this side, combine my like terms, maybe this factors, yes it does. And I get two answers, x equals 3 and x equals negative 2. Again, you always have to go back to your original equation and plug these numbers in to see if they work. If I plug in 3, 18, positive number, okay. Plug in 3 here, 9, that's okay. Plug in 3 here, 2. 3 works. Plug in negative 2, I get negative 12 right away. I just have to find one place where you have a negative inside a log to cancel something out. Now, I'm going to do this without the shortcut as well. So if you were solving this equation and you didn't see the shortcut and you wanted to do it the regular way says you need to get a single logarithm. And if you have logs on both sides of the equation, that would mean you'd have to move one to the other side in order to combine them. So what I'm going to do is I'm going to move the log 6 log 6x over to the other side by just subtracting it on both sides. And then I have a log law that says if you're subtracting two logs with the same base, you can divide, so I divide by 6x. And now I have got this to be a single logarithm. What do we do next? Once we've got the single one. Right? The step that you forget. So what would we do next once we have a single logarithm? We use the definition and we say, what's the base here? The base, since it's not written, is 10. What's the exponent? It's 0. It would equal x plus 6, x minus 1 divided by 6x. What is 10 to the 0? 10 to the 0 is 1. So what I'm going to do is x plus 6, x minus 1, all divided by 6x. Now I have to remember from previous years, how would you solve a rational equation? Well, you would solve a rational equation by getting rid of the fraction. Can you see that you could multiply both sides by 6x? That would give you 6x equals x plus 6x minus 1. And all of that extra work to get to the same place we would have been in our shortcut. Why, and probably why I call it a shortcut, because we would save all that work if we know about that shortcut. Okay? But had you not known about the shortcut, it would still work. Right? This is the classic way of solving all log equations. In fact, the majority of log equations have to be solved by getting a single logarithm, using the definition, right, here's the star, using the definition to change it to exponential form, and then it turns into an equation you've solved before, and you can use your algebra skills from grade 10 and 11 to solve for x. In this case, we had to factor, solve a quadratic equation. If we look at part B on this one, it had 3 equals log 2. Oh, we were done. 3 equals log base 2 of x plus 2 plus log base 2 of x. And this one we won't be able to use the shortcut because we don't have a log on both sides. Okay? We do still combine things to get a single logarithm. And since we're adding, that would be multiplying. Once you have a single logarithm, what's our next step? Use the definition, change to exponential form. I'll just distribute this like x squared plus 2x. And it turns into a type of equation you solved before. Oh, it's a quadratic equation. How do I solve quadratic equations? I make one side equal to 0, so I'll subtract 8 on both sides and factor. And finally, the last thing you have to do is go back to your original equation, and you have to plug in 4. Here we get a 6, here we get a 4. Both of those are positive. Put a check mark there. Plug in negative 2. And this one is 0, and this one is negative. Both 0 and negative aren't allowed. Can't take the log of a negative number. You can also never take log of 0. Again, if you think of your parent graph for any logarithm, all logarithms have an asymptote here. All logarithms go through the point 1, 0, and they go through another point, whatever the base is, comma 1. This is your log graph. This log graph tells you about its domain. The only x values that are allowed are when the x values are positive. 0 is not allowed because of the asymptote. Negatives are not allowed because there's nothing that exists on the graph there. The domain is x is bigger than 0. And at this point, I'm a little frustrated with the textbook because we've done 4 examples so far. And in each of the 4 examples, the positive number worked and the negative one doesn't, which is just enough for students to start to think, oh, if it's a negative answer, I put an X through it. If it's positive, it works. That is not true. I can create an example where I give you 2 answers, they both don't work. I can create an example where you get 2 answers that both work. I can create an example where the negative number works and the positive one doesn't. And I have some of those for you. We're going to do them a little bit later. But just to be aware, if you're starting to think, oh, if it's negative, I put an X through it, that is not the case. You always have to verify it by plugging that number back into the original equation. And if at any time in the original equation you have a negative number or 0 inside the logarithm, that's when you will exit out. If you plug it in and it's always a positive number, then that value can work. All right, questions that you can circle for this one are 11 and 13.